Okay, our final problem today. The length of the chord AB is 6 centimeters. The length of the arc AB is 9 centimeters. Find the central angle theta correct to 4 decimal places. Then give the answer to the nearest degree. All right, so I'm just going to go R right here for the radius. We don't know what the radius is, right? Put an R there also, I suppose. I'm just thinking off the top of my head, formulas for trigonometry, formulas from geometry, things that we might have to be true about this. We need to, of course, relate the arc length to the segment length AB. What you might recall, going back to trigonometry is where we learned this, is arc length, if theta is in radians, is just the radius times the central angle. So radius times theta is equal to 9 is a true statement here. Again, I'm going on the assumption we're going to do theta in radians, so that's fine, we can go ahead and do that. So that tells me that R is equal to 9 over theta. That's useful because I want to know what theta equals, right? There's two variables, R and theta, so having a relationship between the two allows me to, if R shows up in my problem, to throw it out and put something in terms of theta in. The other fact that I know about this is a triangle, right? And for theta, R6, the law of cosines and law of sines both are alive and well. Okay. The law of sines requires me to do like R over sine of this and 6 over sine of that. So that gets an angle over here that we don't even have involved. Let's call it alpha over here. Law of sines would get some extra angle involved in this problem that we really don't want to get involved, right? Law of cosines, 6 squared equals R squared plus R squared minus 2RR cosine of theta. So there's a formula involving simply R and theta, and that's workable. So we're going to go law of cosine in this. So law of cosines, just to recall, is A squared equals B squared plus C squared minus 2BC cosine of A. That's the law of cosines. Whatever side this is, this angle should be opposite that side. Whichever two sides are not this side, go right there and there. So in the case of this is the A and this is the B and the C. So A squared, which is 36, equals B squared plus C squared minus 2BC cosine of A. So in the case of this problem, little a is 6, little b and little c are both R, big A is theta. And then, since R is equal to 9 over theta, everywhere we see an R, we put a 9 over theta, and that'll get everything in terms of theta. So, 36 equals 81 over theta squared plus 81 over theta squared minus 2 times 9 over theta times 9 over theta cosine theta. And that creates for us an usable function, right? Now one last thing, just looking at the picture I can see very clearly theta is bigger than 0. I can say it's less than pi. Obviously less than pi because pi would be a diameter, right? That's not very good. That'd be pi radians, right? In order to have a 9 centimeter here and 6 centimeter there, it's got to be between 0 and pi. So with that in mind, I know it doesn't equal 0, so obviously these aren't dividing by 0 here, right? I'm allowed to, at this point, multiply by theta squared, which theta squared, this ends up being theta squared on the bottom. That'll get rid of the fractions, make it a little bit easier to deal with. So I'm going to multiply this entire thing by theta squared. Term 1, let me just underline terms. This is a term, this is a term, this is a term, and all that stuff is a term. So those 4 things need to be multiplied by theta squared. Okay. So, theta squared times 36 is just 36 theta squared. 81 over theta squared times theta squared is 81. 81 over theta squared times theta squared is just 81. this theta squared cancels that theta squared, leaving me with 2 times 9 times 9, which is 162 cosine of theta. And just like that, I've created myself a nice function here that if I solve that, if I can find the theta that makes that true, that's the theta that's the answer to this question. So, if I'm going to use Newton's method, what do I have to do?
Theta equals 0.
Excellent, got to get it equal to 0. So I'm going to move everything to one side. I'm just going to move it over here to the left. So 36 theta squared is perfectly fine where it is. Plus 81 becomes minus 162. Minus 162 cosine of theta becomes plus 162 cosine of theta equals 0. And be careful with the law of cosines. These are constants. This is attached to the cosine, so subtraction is not possible there. A lot of times these end up being the same number in a situation like this, and it's really tempting. Oh, the 162's cancel. But the cosine is attached to that one. There's no cosine attached to that, so subtraction is not possible. So that's my y sub 1. That's my function I'm trying to solve. And y sub 2 is simply its derivative, which is going to be 72 theta minus 162 sine of theta. Derivative, of course, of 162 is 0, so it just goes away. So I got my y1, I got my y2. The only answers I care about are between 0 and pi, so when I set up my window, if I just go from 0 to pi, anything that happens on that window matters. All right? So I go here, type in y equals, of course I'm going to use x instead of theta when I type it in, so 36x squared minus 162 plus 162 cosine of x. Clear this out. I'm going to type in 72x minus 162 sine of x. I'm going to turn off function 2, because again, all I care about when I'm trying to find guesses is things that make this true, right? All right, and again, my window, I'm going to go from 0 to pi, and I might even go from -5 to 5. It doesn't really matter, just as long as 0 is visible on your screen. And notice I am in radians. Make sure you're in radians when you're doing this. Hope it goes back up. There it is, okay. So that kind of looks like it hit 0 right there, but I'm not sure. This one definitely hit 0, right? So 1, 2, around 3. So maybe I'm going to guess x sub 1 equals 0 and x sub 1 equals 3. Let's just do 2 guesses, see if either one of those comes out to the right answer. Because again, I can't really tell. Maybe that hit 0. Doesn't seem like it should, does it? Actually, no, it would, because cosine of 0 is 1. 162 times 1 is 162, minus 162 plus 0. So actually 0, 0 is an answer, but obviously it's not the right answer. So let's just throw that one out. If theta is 0, then it wouldn't open up at all. So the answer we're looking for is very close to 3. So if I go back here and use my Newton's method, program 1, enter, guess 3, 2 point, and did it say the specific number of decimal places?
Nearest degree.
Nearest degree. Okay, so nearest degree. So let's go. These are radians of 2.991563136 radians. Alright. So again, we found the answer in radians. That's what's going to happen anytime you do calculus. Calculus finds your answers in radians. Alright. So once I've found my answer in radians, I want the nearest degree, so I need to convert 2 degrees. The conversion factor is pi radians is equal to 180 degrees. So it's just a basic algebra 1 type conversion just with this fact. So radians cancels radians. So if I just take my answer times 180 and divide it by pi, and notice I just hit answer, so the last answer is this right here. 171.4039419, so 171 degrees would be the answer here. Nearest degree. If it did specify degrees, if it said find the angle, you know, you can definitely give me the answer in radians, but if they do say nearest degree, make sure you do that conversion.